All right, so we are looking at solving absolute value functions today. We're going to look at it with equals. We're also going to look at it with inequalities. Okay. We're going to look at word problems, how to analyze them, how to read them, how to know what to write down from the words given from a word problem, and then also showing all the work by hand and so on and so forth. So let's go ahead and begin with solving and graphing equations. Okay? So writing equations from these words, we're going to be able to figure out what exactly are we going to do as far as work-wise to set things up. Okay, so when setting up a word problem involving absolute value, the absolute value represents the distance from a point. And just so that you know, it's the distance from the center. Okay? And the center from the absolute value function was 0. Basically, the axis of symmetry. So x equals 0, that was the center. Okay? If this was shifted, let's say 3 to the right, your center is going to change. So let's say I shifted it 3 to the right, and that looks like 1, 2, 3. Now the center is at x is equal to 3. And the reason why I'm showing you this, and it has some correlation with transformations, is there's a shortcut to use like on SAT and ACT, that if you know this center, what I'm talking about, these are even easier than what they are. Okay, you just show a lot less work. Absolute value is used when the solution can be above or below the stated value. Okay, so this above or below, this is a big part of what you're learning today. Okay, the above and below is going to be talking about a plus or minus. That's basically saying you're looking at the extreme to the right and the extreme to the left. Okay. So here we go. Let's look at problems so that we know what this is talking about. To solve absolute value, you must first isolate the absolute value sign. Guys, what does that mean in layman's terms? Not get x by itself, but get what by itself? Get the absolute value by itself. So let's say that I have the absolute value, we have 3 and a minus 3 plus 5, and this is equal to y. Your goal is to move all of this extra stuff over to the other side so that you can isolate the absolute value and have it on its one side all by itself so that you can work with it from there. Okay, so absolute value needs to be isolated. Okay, so we're going to set up 2 equations from here. So I'm going to break this down to 2 equations. And notice, what's in the absolute value is going to be written down exactly the same 2 times. These are those 2 equations that I'm talking about. Now here's the other part. Whatever it's equal to, you're going to do the positive version of that and the negative version of that. Who can tell me why? Perfect. The absolute value of this is x. And the absolute value of this is also what? X. So they're both, like Anika's saying, they're both positive. They're both the same answer. But the reason why we're doing a positive and a negative is because of this. These would give the same answer. You with me? That's why we're going to set what's on the right side of the equal sign to a positive and a negative that you see here and that you see here. Questions? Okay, so that's step 2. Step 1, isolate the absolute value. Get the absolute value by itself. Step 2 is to set up 2 equations, one with the positive form and one with the negative form. Okay, and then just basic algebra 1 from there. If I add 32, I'll get 32.5. If I add 32 to this negative 0.5, I'll get 31.5. Questions? Okay. So, last but not least, we're going to talk about inequalities. So inequalities are basically the same setup. You're going to have a plus or minus version, The only difference is that you're going to be looking at inequalities rather than just equals. So here we go, watch. This stuff in the absolute value, I'm going to write down without any absolute value. So it just disappears. I'm just looking at the stuff inside. And I'm going to do what I did over here. 2 is going to be a positive and a negative. So a positive version of what's on the right side of the equal sign, and the negative version of what's on the right side of the equal sign. But the big thing that people tend to forget with inequalities, a lot of people forget it, is look what happens to that inequality symbol there. It flips. Why do you think it flips? Why did that one flip but the other one didn't? Because I multiplied by a negative. Because I had this multiplication by a negative, you learned in Algebra 1 that if when you multiply by negatives, you flip the inequality. Okay? Alright, so then from there it's Algebra 1. Add 7, and we get x is greater than or equal to 9, which is way over here. And then we add 7 to a negative 2, and we get x is less than or equal to 5, which is what we have over there. So it's a disjunction on this one. It's like they're going 2 different ways. And if you were to actually write this out like interval notation, you would say, let me write that over here. You're going to say from negative infinity to 5, closed on 5, open on negative infinity, and you would put union from 9 to infinity, closed on 9. Just in case you're asked to do interval notation, I wanted you to see both. Yeah?
I'm confused on why you would switch the sign because you're not multiplying.
So and that's the thing. I know that it doesn't feel like you're multiplying by a negative, but when you do this plus or minus over here on the right side, that's exactly what you're doing. You're multiplying that entire side by a negative. Okay? Because of this, Anika. You're saying, we know that the positive will give me still the same answer, that if I were to multiply this by a negative, I get the same answer here. And I know that you see this negative kind of inside, and it almost feels like you should multiply the negative over here in front of the x minus 7, but it's still the same thing if you were to multiply it on the other side. Cool? Alright, that's a good question. Alright, so let's move on down to this second part that talks more about the word problems. Okay. So, right here and here, there's a reason why this first one is equals, and there's a reason why this one is an inequality. So quickly read that small little paragraph and you tell me what is in the word the problem word-wise that tells you that you should have an equal sign. What do you think? Anyone? Maximum and minimum. That's exactly it. So the maximum and minimum is why it says equals here. An inequality is for obvious reasons going to be an inequality. But here's the thing. An inequality will not say the max and the min. Because if you're talking about one max and one min, there are only 2 answers. But the absence of it saying max and min is going to default to the inequality. Okay? And there's a little bit more to it too that you have to read context clues wise. It says bottles manufactured in a certain factory have a volume of 250. That's your center, guys. With a margin of error of 20 milliliters. So look at this visual. If the center is at 250 and the margin of error is 20 milliliters, it's saying 20 to the left, 20 to the right. You with me? So over here it could be 230 or it could be 270. Are we good? So that's that margin of error, if you will. It's like playing darts. If you play darts and you're throwing darts at the same time, or consistently at some center, that's your center. But sometimes you might be a little bit off. And if you're throwing it at a dartboard or whatever, right? And let's say you hit the bullseye a couple times, but then sometimes you're over here and you're a little bit off. These are the jump errors, that standard deviation kind of feel to it from your center. Okay?
So the 20 is the margin of error?
Yeah, so here we go. This number that's always by itself is the margin of error. That's this. How far off point or the center are you? And the center is going to be dictated by what's given to you here. You tell me. Let me not highlight it too dark because then you can't see it. What's the center there? 7 or negative 7? 7. Because it's always the opposite, right? What's the center here?
So if it was x plus 7, it would be negative 7?
Yeah, so if it was x plus 7, the center is at negative 7. If it was x plus 3, the center is at negative 3. Because with x, we always interpret what? The opposite. Okay? Alright, so let's go to our problem here. So this is just another problem, and I'm going to show you what we do graph-wise. You can see that the center is at positive 7. And the jump, the margin of error, left to right, is going to be 5. So it's like subtracting 5 and adding 5. Okay? And that's how we quickly get 2 and 12. Just a good visual for your shortcut. Questions? Because otherwise, we got to go back to what we were saying with Anika. We have to make the positive and the negative version of the right side number. And then we're just going to do basic algebra. Add 7 to get 12. Add 7 to get 2. You're going to learn today that even though, and I know this is weird, but you'll learn why as we learn more throughout the year, even though we got an answer, sometimes one of those answers doesn't work if you plug it back into the original equation. Sometimes both of them do not work, even though you mathematically got numbers. And if they don't work when you check them, guys, you're going to have to check all your work.
Why does it say minus? Oh.
Okay. When you check it, if it doesn't work, they're called extraneous solutions. So extraneous solutions are the ones that are basically extra that don't work when you check it. So part of the bonus points we're going to compete today, part of the bonus points that you do in your groups, I want you to always check your work. And I will reward you with points when you're checking your work. And even on quiz, the next class, I want you to check your work for extraneous solutions. Alright, so one more example, and then we'll start doing bonus points. The absolute value of x minus 3, we could say the center is at 3, and the jump is 4. So 4 to the right gives you 7, 4 to the left gives you negative 1. But with the inequalities, I need to know, am I shading like this, or am I shading the conjunction? Okay? So we do have to go to work as far as, notice how this is x minus 3, both of those are the same. And then we go to, over here I had a 4. So I'm going to have the positive version of what was there, and the negative version of what was there. And with the negative, I have to make sure that I flip the inequality from what it originally was showing. Okay? These will get more difficult. These are the easy ones right now, but the steps and processes are the same. Okay? So when we add 3, we get 7. X is less than or equal to 7, which would look like this. Starting at 7 to the left. And then x is greater than or equal to negative 1, which is here going to the right. but we want to know where they overlap. So this is in between. It's called a conjunction. Again, disjunctions, they go away from each other. Conjunctions go toward each other and they overlap. And you could do it like -1 to 7 if I asked you to do it in interval notation. Okay, any questions that you have for me? Yes?
So your answer choice, your answers that you get should have opposite facing signs on inequalities.
No, so this one right here, x is less than or equal to 7, and x is greater than or equal to -1, could also be written like this. So x is less than or equal to 7, but it's also greater than or equal to -1. So you could have it like this. If you have it where you can fit the x in between the boundaries, it's a conjunction. But if you have them where they're separated and they're looking different places, like you had up here, see, you can't put the x in the middle of this and say that x was less than or equal to 5. These are not facing correctly as far as what I have. And the way I put that x is less than or equal to 5 and x is greater than, it doesn't make sense because of the fact of, look at the numbers. How can you be less than 5? You see what I'm saying? It wouldn't line up. You would have to write it like x is less than or equal to 5, but it doesn't make sense because if you wrote it that it was greater than or equal to 9, this doesn't make sense like a number line. Okay, like let's say let's put 5 and let's put 9. That doesn't make sense because that's not how the number line goes. It goes from negative to positive. So it goes from negative all the way to positive. You understand? Okay. So now let's do our first problem together with our groups. And I'm going to give you 3 minutes, and I want thorough work. So put all the work that you think we need to put by hand, and we're not going to use a calculator. Okay, so your first example, and I'll pause the video, is this one right here. Alright, so resuming the video real quick. The way I want you to do it, and if not, just do it for the next problem, is copy the problem first and show the step 1 is to isolate the absolute value. There's step 1. Step 2 is to break this up in 2 equations that show the positive version of this and the negative version of this. And now we're going to solve by hand. So we will add 1, divide by 2, and that could be a possible answer. And then we will add 1, divide by 2, and this could be a possible answer. You with me? So now we got to check it. So when we plug this in, follow me please. I plug it in, I get 6 minus 1 is 5. Absolute value of that is 5. That one worked. Okay? And this is how I want you to do it, like on the quiz and test and stuff. It tells me that you checked it. Let's put -2 right here, bless you, for x. So if I plug in -2, I get -4. Minus 1, I get -5. Absolute value, I get 5. So this one also worked. Now going forward, I want you to do like this for bonus points as well, okay? Because look, I'm giving you 10 for writing this, 10 for writing these, 10 for each of the answers that you got, and 10, maybe even more, of showing that you did check the work. You with me? Yes?
Could you also just like actually write out plugging it in? Like that?
You could write out plugging it in as well, yeah. Like some of you would show the work of plugging it in. That's more preferred. Yeah, for sure. Because that's more thorough. So 1, 2, 3, 4, 5, 6, 7 is what I'm looking at. Now, because these are equalities, I want to make sure that you know you don't necessarily have to draw a number line and show that 3 was an answer and show that -2 was an answer. You don't have to do that because there's nothing to shade, okay? But if it was an inequality, something that looked like this, then you would do the shading. And you guys recently did things with inequalities with your project, with the linear programming of if it's below or above the y, or you know what I'm saying, you shade above or below the line. So there's a good indicator of when you see the inequalities, then you will shade. Okay, so your next problem.
So if it is an inequality, we have to write out the little thing.
Yeah, so if it's an inequality, you would do the number line, and then you would shade where it goes. And it could be something that looks like this, which is a disjunction, or it could possibly look something like this, okay, which is a conjunction. And inequalities will look like one or the other. It won't be where an inequality, it didn't work, and it was extraneous intervals. You see what I'm saying? So an inequality, the intervals will work, but if you have an equality, that's when you're thinking about extraneous solutions. Some may work, some may not. Do we understand? Okay. So now let's go to a little bit more involved. And our next example is going to be 3 times x plus 2 in absolute value minus 1 is equal to 8. And I'm going to give you 2 minutes. All right, so let's work this one out together real quick. Isolate the absolute value sign is first. Be careful. Because if I'm subtracting 1 on this side, that means I'm going to add it to the other side. Now I'm multiplying, okay, let me show you. It's 3 times all of this stuff, so to get rid of the 3, we're going to do the opposite or inverse operation. So we have to divide by 3 so that we've done all this work to isolate the absolute value. That's step 1. Step 2, from what we're learning today, is that we're going to break this up. So whatever's in the absolute value, you're just going to copy it just like it is, but without the signs. And now you're going to do the positive and negative version of whatever is over here. Everything that's over there, you're going to do a positive and negative version of it.
What did you do with the negative one? You just added it?
I just added it to both sides. So you'll have a positive 3 or a negative 3. So now if I subtract 2, I get 1. If I subtract 2, I get negative 5. Okay? Now I got to check it. So with me, please. Yes, you can check it right here. And all day, you can still know if it's right or wrong. But I tend to, at first, not encourage students to do that. Because if you made a mistake here, what you're going to check it with is an incorrect equation. So I tend to encourage students, until they get really good at it, to check with the original problem. Okay? So here we go. Let's plug in 1, and with me, please, I would get what? 3. Absolute value of that is 3 times 3, 9 minus 1, 8. So 1 works. Okay? Let's try the negative 5 with me, please. What would I get? Negative 3, absolute value, 3 times 3, 9 minus 1, 8. This one works. Okay, so here we go. Highlighting green. Each green is 10 points. So there's 10. Just rewriting it. Isolating it is 10. 10 if you got 1. 10 if you got negative 5. 10 if you checked. 10 if you checked. 1, 2, 3, 4, 5, 6. Okay, so this next one, be careful of how you set it up. It looks a little bit different. Steps are the same, but you got to be careful on certain parts. The absolute value of 3x plus 2 is equal to 4x plus 5. I'm going to give you just a little bit more time so you can talk about it. All right, look up here, please. First of all, this one's a little bit different. Step 1 is done, though. The absolute value is isolated. So what you would do to start this off is you would write this. and you would put the positive version, which you don't need to do what I'm doing, but I'm just showing you for instructional purposes. But you do need to put this negative version, because how else are you going to know to distribute that to get negative 4x minus 5?
What if we just distribute it without, like, we didn't put, I just distribute.
That's okay. Yeah, that's okay. As long as you get that, that is the goal. Here, nothing changes. So you have 3x plus 2 is equal to that. 3x plus 2 is equal to this. Now look, I know that I see x's, and I know that this 4 is bigger and already positive. So to me, from what you're going to be working with, if I subtract it, I'm going to have to divide by a negative 1 eventually, which means I have to remember if it's an inequality, I have to flip. So to limit the simple errors, I tend to tell students, try to find the positive as fast as possible. And then, what? You get negative 3. Over here, I would then add the 4 over to the left, so that I could get a positive 7. Subtract 2. Divide by 7. And now I'm going to quickly check the work. Okay, here we go. I have negative 3 with me, please. I would get what? Negative 9 plus 2. Negative 7 absolute value. 7. On the other side, you got to do both sides. I would get what? Negative 12 plus 5 is negative 7. Those do not equal. So this one is going to be an extraneous solution. Mathematically you solved it, but it doesn't work when you plug it back in. Now let's try this negative 1. I would get what? Negative 3 plus 2? Negative 1, right? Absolute value you get 1, and I know I'm going a little bit over. I'll let you come back a little bit over from lunch. Let's plug in negative 1 here. What do I get? Negative 4 plus 5? 1. So this one did work. Your points would have been this. Copying the problem. Okay, so let's do green as 10. Let's do orange as 20. Okay? So I want you, if you caught this, and some of you went straight to here, and that's okay. I want you to do either one. This one would be 20. This one would be 20. And then if you got a negative 3, give yourself 10. If you got a negative 1, give yourself 10. If you checked it, give yourself 10. And if you check this one over here and you wrote that it did not work of some kind, give yourself 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 100 points would be max.